Hello everyone, this time I'm going to talk about practical flight mechanics and what limits the duration of zero-G parabola flights. Short introduction: zero-G parabola flights are flights where normal airplanes, usually airliners, are used to simulate weightlessness for a very limited amount of time by flying in a parabola following the Earth's gravity with zero lift or close to zero lift and engines just countering the aerodynamic drag. You try to keep the acceleration at zero and just follow Earth's gravity in a free fall so that the passengers inside the plane or any experiment or payload inside the plane essentially feels weightless. Now this can only safely be done for a few seconds, usually somewhere between 30 or 40 seconds, because obviously you're accelerating along with gravity, so you're accelerating at 1g, and at 1g there is only a limited amount of time until you reach a certain velocity. If you start with ascending at a certain climb rate, then at 1g your climb will slow down and then you will start to descend at increasing speed, and at some point there is a safe top speed for the aircraft, and on the other hand there's a top speed at which you can enter the parabola, and these limit your parabola time. However, this is not the full story, and that might lead to some misconceptions, because now the common question is, why didn't they, for example, use the Concorde for a parabola flight? Which is a very justified question. Of course, there are many factors influencing this, like operating cost and interior design limited by fuselage width. So the Concorde had a very narrow fuselage, so you couldn't really do very interesting things inside its interior, so you couldn't really use it very well to train astronauts or do very interesting experiments. Still, there is more to it, because it's not just the top speed that limits your parabola time. Of course, it is an influencing factor. You can only go so fast, and that divided by 1g acceleration times 2, because once during ascent and once during descent is your top time during a zero-g parabola. But that's not all, because the plane's maneuverability also has to be taken into account, and the Concorde was not very maneuverable even compared to a regular airliner. During a normal airliner flight, you are usually exposed to no more than 1.25 Gs or 0.8 Gs, because they don't maneuver all that hardly. Now, a normal airliner is still designed to handle a bit more, so that harder maneuvers can be flown in emergencies, increasing safety. Now, this is of course the certified load before additional factors of safety are added to the construction, which you should not use. But the certified G-force limit on most airliners is somewhere around 2.5, in extreme cases maybe 3 Gs, while the actual used G-forces is usually somewhere between 0.8 and 1.25 Gs, as the airliner is usually very close to level flight and just slowly pitching up or down during ascent and descent, or turning very lightly. And the Concorde was designed with a much lower additional G-force factor. The Concorde was only really designed to handle up to 1.5 Gs. Now this impacts the maximum duration of a zero-G parabola, and we can calculate how. Most airplanes lack the top speed or the air brakes to keep a vertical dive safe. So you can't vertically dive in most airliners safely, because eventually you will reach a speed where the airframe will disintegrate and your air brake is not strong enough to completely counter the gravity. Therefore you have to start recovering from your dive with a turn up in time, and that turn up will take longer if you can't pull as much G's, and therefore it will take away more time from your dive, because you'll still be accelerating during that turn up, and you still do not want to go through your maximum certified speed. And we can set up a formula approximating that, neglecting a few very complicated additional factors that only impact that by a few percent. Since we want to come out in level flight, our overall amount of upwards and downwards acceleration must be equal. We have a constant downwards acceleration of 1g, and now we can add upwards acceleration at the end using our wings, but this is taking away time from our 0g parabola. However, we can still fly a 0g parabola because the time taken away is less than our overall dive time, because we can accelerate upward at more than 1g, so we have to accelerate for a shorter time than our overall dive, and thus still have time left for a parabola, which means the time we will spend in our recovering turn will be the overall time of our dive divided by our maximum g-force. Now we still have to add in a factor because we're in a dive, so we're applying our lift at an angle. We're not accelerating straight upwards, instead flying a round turn. If we had a perfectly vertical dive, we would have to add a factor of pi divided by 2, or roughly 1.57, because that is a quarter circle in radians. However, 0g parabolas usually don't end at a close to vertical dive, but more something like a 60-degree dive, so this factor is more around 1.25 roughly, leaving us with a parabola dive time of our maximum speed divided by 1g multiplied with 1 minus 1.2 divided by our maximum g-force, which leaves the Concorde, which has a maximum g-force of 1.5 g, using only about 20% of its actual top speed for the dive. The same thing goes on the climb up, because you also have to turn upwards before climbing up into your 0g parabola. Add to that the fact that the Concorde didn't have a great thrust-weight ratio and couldn't really keep its top speed while turning upwards at its ceiling altitude, and that the Concorde could not reach its top speed at sea level altitude. And it turns out that an airplane with a maximum G-load of 2.5 Gs but a much lower top speed is much more practical, because it can actually use more than 50% of that top speed for its 0G parabola, giving you an overall longer 0G time, and then the Concorde is still more expensive and has a much narrower fuselage. So this is one reason why speed is not all in 0G parabolas, and why the Concorde would not be a great 0G parabola plane. I hope you found this exemplary little introduction into evaluating and thinking through flight physics and approximating airplane limitations kind of interesting. I'm always open for any questions related to aerospace engineering or physics, and as always, thanks for watching.